Hello, this is Jeff Hamrick at Rhodes College again, and I'm going to talk with you briefly about using SPSS to run a one-sample t-test. That is, to test the null hypothesis H sub naught mu equals mu naught. So what I have here is the body temperature and resting heart rate data by gender that we've been working with at several points throughout the semester. We want to test whether or not, once again, these data, 130 cases, give sufficient evidence to indicate that the true mean body temperature of human beings is something other than the typically postulated value of 98.6 degrees Fahrenheit. So we've already tested this idea. We've run this hypothesis test in Fathom using randomization techniques, and we've also used Fathom's drop-down functionality, and we've also done hand calculations with Mathematica support, but now let's use SPSS's built-in functionality. So you go up to Analyze, and the thing you want to do is compare means. This first choice here, means, generates some descriptive statistical information for you. That's not what you want. And these remaining choices down here are for two-sample t-test or multi-sample t-test. We're not interested in those. We want the one-sample t-test option right here. I'm going to click on that to bring up the wizard. These variables here can be toggled back and forth. You can run multiple t-tests simultaneously. I'm not going to do that. I'm just going to test body temperature. Notice that the ruler here in body temperature indicates that SPSS views the data as being quantitative in nature rather than ordinal or nominal. So this is ready to be processed by the one-sample t-test wizard. The test value that you put in here is the value of mu naught under the null hypothesis. So since, sort of the wives' tale, the heuristic is that human body temperatures are on average 98.6 degrees, that this body temperature is normal, that's the value that I'm going to put in there. We can also generate, as part of the use of this wizard, an afterthought, namely a confidence interval for the difference between the true population mean and the null hypothesized mean of 98.6 degrees. So you can change the confidence level by clicking on options and switching this parameter to something else. If I want a 94% confidence interval, I can just enter 94% right there. Okay. These two options here have to deal with missing values of the data. We've cleaned the data a lot in this class for you so that you don't have to deal with that issue a whole lot. So generally speaking, you can ignore these options right here. Press continue, press OK, and then let's take a look at the output. So we see here that the sample mean of the data for the 130 subjects is 98.249 degrees. In particular, when we run the hypothesis test against the null hypothesized value mu naught, 98.6 degrees, we get a student t-test statistic of minus 5.455 with number of degrees of freedom equal to the sample size minus 1. The p-value in this particular case, though it's associated with the two-sided alternative, is basically not distinguishable from zero. So we're going to strongly reject the null hypothesis that the true mean body temperature of human beings is equal to 98.6 degrees. In addition, we're given a confidence interval here. It's a 94% confidence interval. You need to be careful here, though. This is a confidence interval 94% for the difference between the true population mean and the null hypothesized value of 98.6 degrees. So if you would like to get a confidence interval for the true population mean, you need to add 98.6 degrees to both this lower bound and this upper bound. Okay? So if you keep that in mind, you'll be able to interpret and use this confidence interval here. But that's how you do a one-sample t-test in SPSS. It's not very complicated.